Hi, my name is Will Dawson, and this is my LE4 explainer. So, in the LE4 quiz, we were given this linear equation. Now, this is in matrix form right now, and I'll talk to that in a little bit. But first, to find a solution for this matrix, we had to do something called reduced row echelon form, or RREF. This is a way to simplify a set of linear equations so that it's easier to find solutions for. So if we equate the RREF, which you would typically do this with a computer, you can do it by hand, and I'll get into doing it by hand in a little bit. But if you crunch this RREF, you simplify the matrix to 1, -3, 3, 0, 1. This bar is an equal sign, by the way. 0, 0, 0, 1, 2, -1, zeros all the way through on the next rows, and then close off the matrix. So what this matrix is you have columns and rows. And columns, these can be represented by different variables such as vectors, and rows are different equations. So initially we were actually given an equation that would have x1 plus x1 or negative x1 plus 3x2 minus 3x3, so on and so on, equals 5. And we were given 4 sets of equations. But a matrix simplifies that a lot because you don't have to write x1, x2, x3 for all of those. You just have numbers. And what I said earlier was this bar means the equal sign. So this means -1 x1, 3x2, -3x3, -2 x4, 5 x5 equals 5, and then that applies for all these rows, which are different equations. And RREF, as I mentioned earlier, is a way to simplify these linear equations and matrices. And you have a few different operations you can do that are legal to make it so it's the same set. You can add and subtract rows. If you remember doing two-system linear problems, so you would have two variables that you're trying to find, and you'd have two equations that the variables are shared between, you would sometimes add them together. And you can add a row to another one. So what I mean by this is, say I want to get rid of this 3. I wouldn't actually add a row, I would probably subtract it. I would probably subtract row 3 from row 1, and that would get rid of that 3, but it would also get rid of that 1 as well. So there's multiple ways that you can manipulate these. You can also multiply a row by a constant. So if you can multiply a row by -1 or another number to scale them to allow you to be able to simplify into RREF, and you can rearrange them. That's really useful by hand. But once it's in RREF, there's a few rules that are RREF doesn't have a set way of finding it. You just manipulate the matrix until you reach a certain criteria, and I'll go over the criteria right now. So you need pivots. So these ones right here, these are called pivots. Pivots are the first number in a row, and they have to be ones. If they're not ones, they need to be simplified till they're ones. So you see the first number in row 1 is a 1, and then the first non-zero number in row 2 is a 1. And another valid pivot location would be right here, but we don't have one in this instance. And then above and below pivots can only be zeros. So you see how we have 3 zeros right here, and then 0 right there, and 2 zeros right there. That means it's valid. As well as the pivots should move down in a stair-step pattern. So you shouldn't have a pivot over another pivot, and they should go like this. Or this is also perfectly valid, that it goes over 2 and then goes down 1. This is where, like, that ordering that I talked about earlier, you can move these rows around until they're in the proper order, where the pivots go down like a stair. And other than that, and also there's another just rule for cleanliness, or just, how do I put it? Just a nicer way to put it is you put all the zeros at the bottom. So you see how these 2 rows at the bottom are nothing but zeros. That is another rule to RREF, but that one is just taken care of by reordering rows around. And what this means is we actually get an equation like this. So let's say, as I mentioned earlier, columns can be represented by variables. And let's pick a variable like, I'll do v1 or v for vector because a lot of times you will have these columns be represented by vectors. And engineering, we use these vectors a lot whenever we're doing cross products, but we have 4 dimensions here, and cross products are in 3D. But sometimes we even have 4D vectors in engineering. Some instances where we have this is where we have a 3D like some sort of force vector, but then we have the 4th vector representing something else about that, such as a rotation or a moment. And we can't have 4D vectors in engineering. They're not very common though. So if we turn this back into a system of equations, we would get v1 minus 3v2 plus 3v3 plus 0v4 plus 1v5 equals -3. And then we would have for this one zeros all the way down, indicated by these zeros, and then 1v4, so just v4, plus 2v5 equals -1. And this doesn't matter, that's just a 0. That's shown here, but in the linear, or in the system of linear equations, I just like leave a space to remind me that there was a 0 there, and so I don't accidentally, whenever I'm numbering these variables, go 1, 2, 3, 4, when that one should be 5. But now we can solve for solutions. And if we think back to earlier algebra, such as in middle school, whenever you're solving for 2 variables and you would have 2 equations, you can only solve for the number of variables that you have equations. And we only have 2 equations here, because these zeros don't compute to any equations. They're just 0 equals 0. So we only have 2 equations, so we can only solve for 2. We can only solve for 2 of these variables. So the ones that we can solve for are the pivots. So we can solve for v1 and v4. All the other ones are what we call free variables. And these can be anything we want. These are independent of anything. We can set them to whatever we want. v1 and v4 in this instance, because they are the pivots, are dependent on the free variables. So if we solve these, we will get, I'll solve for v1 first. So v1 is equal to -3 plus 3v2 plus, or minus 3v3, my bad, minus 3v3 minus v5. And then we solve for v4 as well, since that is another pivot that we were solving for as a variable. And that one's a little bit easier. That's just equal to -1 minus 2v5. And what we will do is we'll do a solution set notation. This is specifically more linear algebra, and this is where we have a kind of like a vector set where we have all the variables. So we'll have like v1, v2, v3, v4, and we'll also have their free ones. So I'm just going to say v2, since that's our first free variable in order, is equal to a. Then I'll do v3 is equal to b, and then I'll do v5 is equal to c. So if I plug a, b, and c into where we have these equations, we get v1 is equal to, and let's do some reordering. We'll do 3a, and then we'll do minus 3b, or b right there, minus c. And then we'll also do one for v4. v4 is equal to, that would be negative 2c minus 1. Okay. And now we can put this in an answer, or a solution set. So we'll do I forget the name of this fancy bracket, around another bracket, 3a, since this is equal to v1 and this is the v1 location. So this is the vector, so minus 3b minus c minus 3, a for v2, b for v3, negative 2c minus 1 for v4, and then c for v5. I extend this bracket down. And then that would be equal to a, b, c equals all real numbers. So we can get all real numbers in actually 2 dimensions. So this could be R2. 2 dimensions with a, b, c being the free variables. So that's all. And this is my explainer for LE4.